Hello, everybody. You can hear me okay? Please give me okay. Thank you so much. So congratulations. You are the iron men and women of the event. You made it to the final session. And I think I can speak for the panel when we say thank you for being here, and thank you to the RISC-V Summit for allowing us to participate in this panel discussion. I think it's going to be a fun time. So my name is Thibeault. I work with Infineon Technologies, and my role is called Partnership and Ecosystem Management. I work in the region based in Detroit area, and I cover the automotive market, and I've pretty much been in the automotive industry for all of my 27, 28 years of my career in different capacities. So we've been talking about RISC-V these last 2 days in great detail, and it's mostly been focused on high-performance computers, hyperscalers, SoCs, and so on. But what about automotive 32-bit microcontrollers? Well, thank you. Yes. Yeah. So Infineon announced it was at Embedded World this year that our next generation of automotive microcontrollers will be based on RISC-V, and so obviously that's a disruptive announcement, and we cannot do this alone. So obviously we've been talking these last days also about the benefits of RISC-V, open architectures and ISAs and collaboration, and so my role as partnership and ecosystem management is to make sure that our ecosystem partners in the region, our relationships are strong and they reflect the strategies with our products and ecosystem in Germany as well, our headquarters. And so I'll let the panelists introduce themselves in a moment, but I wanted to first ask a question to the audience. I'm going to keep everybody on their toes, okay? We're all very much steeped in the automotive industry up here, but who in the audience actually works almost exclusively in the automotive industry? Okay, see, we're outnumbered, right? You guys, the rest of the audience is not very much the, let's say, automotive side of things, but who drove here in a car? Yeah? All right, so you're all in the automotive industry. Yeah. So, I'd like to introduce the panel. Brandy, would you like to go first, please?
Sure. So Brandy Goolsby, Business Development and Sales, Embedded Software, Vector North America. And for those in the room that are not familiar with Vector, Vector is a software company, and we're also a technology partner to OEMs and Tier 1s in automotive and related industries. We provide development tools, software solutions, and advisory services.
Go ahead, Dan.
Oh, okay. Dan Mender, Vice President of Business Development. I've been at Green Hills for about 25 years. The company itself has been around for 40 plus years, focusing on advanced software solutions that cover a broad range of capabilities from operating systems, hypervisors, compilers, debuggers. And over that time, we've developed a unique subject matter expertise around helping our customers build systems that can achieve the highest levels of safety and security.
All right, Rich Collins, Senior Director of Product Management for our RISC-V portfolio. Synopsys has been developing processor IP for maybe 20-something years or so, but about 2 years ago we decided to add RISC-V compliant processors to our portfolio, and we've since announced and launched several processors from deeply embedded and now to higher performance host or application processors. And automotive has been a big part of what we do. We have some key partnerships with people up here on the stage as well as others, and we're excited to be part of that.
Yeah, Rolf Kühnis. I'm a Strategic Technical Alliance Manager. I'm located in the Portland metropolitan area. And Lauterbach is really focusing on debug tools. And it's not just the gray boxes, and it's not just the hardware. It's really starts pre-silicon, post-silicon, and even field returns. And for us, it's really, we debug from microcontroller to client compute up to HPC. So we provide possibilities for all of those.
Yep, so thank you very much. In my role, I work very closely with all of these ecosystem partners, and we hand-selected these participants. We work together very closely, and so look forward to a lively discussion. When you go to business school, you talk about marketing. You always try to position the problem first, right? You don't just try to sell solutions. So at the end of the day, I wanted to kind of open up with what is the main challenge that we see in the automotive industry these days. In the era that we are in, we call it the software-defined vehicle era. And I wanted to kind of open up the discussion to all of us here on the panel, and let's peel the layers of the onion back a little bit. I bet you if you ask every one of us what SDV means, there's 5 of us up here and you might get 6 different answers. I don't know, right? So what is the challenge that the OEMs are facing these days, based on becoming a software-defined vehicle, consumer expectations, and so on? Let's try to analyze that a little bit. What's the problem that the OEMs are trying to solve at the end of the day? Anybody can answer. Anybody wants to go first? We got some.
I can
Okay, Rich, you got it.
Yep. I think, this SDV, software-defined vehicle, it's a good buzz term, but then when you start to put pen to paper, if you will, people don't do that anymore. But basically, the systems are getting more and more integrated, right? As we move from domain controllers to zonal controllers, these large ADAS-type chips are, multiple processors on there, multiple, peripherals, elements, whatnot. And the software that needs to run on that is becoming very, very complex. And in order to achieve a reasonable timeline of being able to deliver to the end customer, you have to have reuse, right? And the one nice thing about RISC-V is by being a scalable architecture, you can build software modules on, say, smaller processors that can then be ported to other, bigger processors in a larger system. And so, in order to be able to do things in a reasonable amount of time, that sort of realization of a software-defined vehicle absolutely has to have that scalability.
Yeah, so vehicle architectures are a big part of it. That is one of the key enablers, and Ethernet's probably one of the biggest parts of the technology chain that enables us to achieve consumer expectations, which I think is updatability is probably one of the key aspects. Does anybody else want to talk about updatability? And yeah.
Well,
Go ahead.
there's actually a number of different challenges that an OEM faces in this software-defined vehicle world, and it's part of it is, as they're moving more and more toward ownership of the software itself, right? Going from relying on a tier 1 or relying on third parties to develop the code and develop the platform for them and send it over to them as a black box, we're seeing a migration, and every OEM's at a different stage of the ownership. And they're evolving to actually take on the development processes and practices that are needed to develop, test, integrate it, and validate the software, which is a major undertaking, It's not easy. So that's a key thing that they're evolving to. And one of the important things that you have to do is you have to find, as you're building this system, one of the things that an OEM wants to do when they're taking on that ownership is they want to make sure they're developing their platforms to be as portable and scalable as possible. So picking the right architecture or architectures that you're building your SDV around and on is very critical and important.
Yeah. So it goes from vehicle.
I just wanted to tag on
Yes.
to both Dan and Rich just a little bit, because you mentioned software complexity, and then you mentioned the need or necessity for kind of being able to build, test, and deploy quickly, right? And so from a vector perspective, there's a couple of things happening over in our world, which is we are seeing our customers, our OEM customers, wanting more like ready to use, like for their use case right now, solutions, software solutions. And so what we've been doing with Infineon and Synopsys and others within the ecosystem is trying to identify how can we pull together what we would call software evaluation bundles. So looking for those pre-integrated, pre-validated, ready-to-use software solutions so that they can raise the starting point and get the developers going quickly. So we're really focused on enhancing that developer experience. And as such, we're also heavily investing in what we call the software factory, which is a term you've been hearing across the industry. But as we do that, we understand that different people are at different places in that development process. And so some companies are at ground zero and they need a full software factory, so the ability to build, test, and deploy. But then there's others that are further along and they may be missing certain pieces of that development process. And so as such, we've been working closely with Synopsys. We had an announcement earlier this year about how we're collaborating on creating these virtualized environments. And that's kind of the control point for putting software-defined systems in place, which is really around the virtualization and the testing needed and required to deploy these new architectures, these new modern architectures that we're calling zonal or ring architectures going forward. So I just wanted to add that little input because that's uniquely how we as collaborators play together to bring those types of pre-integrated evaluation bundles together. And we have the Drive Core evaluation development kit as well. So there's so many different ways we're trying to raise that starting point for the developer to get them going as quickly as possible.
Yep. Thank you for bringing that up, Brandy.
Yeah.
So there's a lot to unpack there. The OEMs, I think you could say, are moving in a direction where they're trying to pivot more into becoming technology companies, yeah?
Yeah.
And so part of it is vehicle architecture, software, and abstraction layers in order for the application that they're now owning and defining to be on their own life cycles versus hardware. So anything to add there, Rolf?
Well, the architectures, like you said, they are getting more complex, and so you really need to do much more earlier. Actually, even you might need to do you need to do software development before you have hardware available. You will have hypervisors, you have different OSs, maybe even different ISAs running your code on. So the complexity per se is really increasing, but I think a lot of what we are providing on tool-wise, like on the compiler or on the testing tools, all in the debugger, is somehow OS agnostic. So a lot of that complexity is somehow hidden, it's under the hood, so the user itself does not really need to care of. But I think it's really a shift also in the automotive industry with that kind of complexity, plus then, okay, now you need to be much earlier, plus you need to optimize your software during the whole life cycle, right? It's, what is it, 15 years we just chatted, all right? Which a company needs to guarantee spare parts.
It is, yes.
And you will get software updates regularly, and you need to ensure that it's not slowing down. So it's like so I was working in the mobile business in the past, and after 2 or 3 years, your phone just gets slow and sluggish, and you buy a new one.
Yes.
I think nobody wants this in a car, right? So you need to ensure that the software is always up to date and really behaves as it should.
Yep. I actually, just traded in a 12-year-old vehicle, for a 4-year-old vehicle. Yeah. Okay, so I mean, that's the problem. The OEMs are trying to adapt into technology companies, and so how can we all, enable that? Maybe we start at the IP level, Rich, yeah? So how does the core itself and RISC-V, you mentioned it in your opening, how does that enable OEMs to pivot into tech companies?
Right. From our perspective, there's 2 aspects to it. The scalability that I talked about, right? Being able to have a single ISA and, basically have small microcontrollers all the way up to, large apps processors, because all of these things will be on a single, device. But the other thing that I think we've found that's we appreciate about RISC-V is it isn't a perfect thing yet, right? So there are extensions that are required for specific aspects of what we want to do. And in our case, we're focused on real-time applications in automotive. And we found that there were some areas where real-time wasn't as prevalent, I guess, when they were defining parts of the standard. And so we've basically gone and used the ability to extend the ISA and add features that we believe make the processors better for real-time systems. And of course, I think from the standards body perspective, we want to bring those back into the RISC-V standard in some way, shape, or form so that others can take advantage of that in the future. Yeah. But we appreciate that ability to add those custom extensions and build sort of more specific implementations that, for instance, in our case, are better for automotive real-time applications.
Yeah. So it's really the scalability of an open architecture ISA that helps the OEMs develop on a common architecture, and the ecosystem needs to develop at the end of the day and So it's this open architecture scalability that helps them achieve their.
Absolutely, and then the customization can't create one-offs, right?
Yes.
So the whole idea of bringing things back to the standard is eventually you want the open ecosystem to be able to support those things, right?
Yeah.
It doesn't help if everybody's building a custom solution, right? In order for it to work, you have to have the ability for anything in the ecosystem that follows certain profiles and whatnot, and the standard will be able to work with, interoperability with other vendors' IP.
Yep. And I would like to mention that, Quintoris is one of those standardizing bodies that we work with, and the intent is exactly that, to help standardize these IP blocks that gets proliferated throughout, not just Infineon technologies, but all of the ecosystem solutions.
Mm-hmm.
Yeah. Okay. Maybe we move up the architecture chain, Brandy. There's actually a quote here that I ran into when I was given some research to prepare for this panel. Let's see, where is it? Uh-oh.
No, it's not my quote.
It was by Associate Professor at the University of Bologna, Davide Rossi. He said, the biggest challenge for RISC-V in the next 15 years will be to create a mature software ecosystem. Yeah? And he mentions that also that's HPC. But the same thing is going to be true for automotive microcontrollers. So Brandy,
What's the date of that quote?
I believe we're in the 15th year of RISC-V, right? I think he's talking about the next 15 years, yeah.
Yeah, from a software integration perspective, and the point is rightly stated, right? It is going to be very complex, but from a middleware provider perspective, a platform provider perspective, one of the things that we are committed to is working across the whole value chain, right? So the full ecosystem, because we sit in the middle and we're like that connective tissue. So we have to make sure at the high level the APIs are consistent with our existing software solutions, but then at the hardware low level details that we have we make the right adjustments, and we're ready for whatever the implementation looks like, and we're there. But we're committed to making sure our products, our Micros is our brand name, but our set of software solutions that support anywhere from your actuators and sensors all the way to the more complex ECUs to your high performance compute are enabled and ready to support those high level APIs for the application activity, but then also those low level hardware details. And so we're gonna have to work super close with like yourself, right, Infineon, to really think through what are some of those challenges that we had in the past, like MCAL driver development, and thinking about extensions that go beyond like AutoSAR standard extensions, thinking about non-standard extensions, and how do we create those that we know our mutual customers are looking for, and then put that back into the open source community, back to your point about open source and creating an environment where we can facilitate collaboration on non-differentiating pipe plumbing, if you will,
Yes.
in order to continue this momentum going as we continue to go forward. Because at the end of the day, the back end is really going to be on what I would say the commercialization of all this openness, because somebody has to make it robust and maintain it for the customer. So that's where our opportunity is from a business perspective. But in order to really move this forward and get the tech where we want it to be, we have to focus on what's that non-differentiating stuff and collaborate and stop holding stuff so close to the vest.
Yeah. So a couple of you have already mentioned open source. So is that part of also Vector strategy to incorporate other operating systems, FreeRTOS, ThreadX, so on into your solutions?
Yeah, we definitely want to work across the full value chain, just because we're that connective tissue. So we have to work with the OS vendors, the silicon vendors, the application providers, and really be able to support our OEM and tier one partners in their journey in terms of how they migrate to RISC-V going forward. And so we're really rallied and committed to the RISC-V open standard.
Okay. Do the rest of you see our customer base moving more and more towards open source operating system? I know you don't say that, Dan, but that's okay. Yeah, he has his own operating system. Yeah, but it is a trend. Let's just put it that way. Yeah.
I mean, it depends. For us, at Green Hills, we're focused on, people come to us when there's three key things: safety requirement, security requirement, or both, and then they're looking for some advanced developer productivity with open source or non-open source solutions. So it really depends on the application. I mean, there's different areas of the vehicle that require different requirements. They have different requirements, and it's not as black and white as that. There's been open source in automobiles and lots of different applications for decades, right? So that's been there, but it's. I don't know how to answer the open source. It's got its place.
Yeah.
I mean, it totally has its place. 100%.
Well, don't forget the certification part of it, right? I mean, just like hardware has to be certified, the software and the tools, everything has to be certified in the chain too. So, that factors into people's decisions, right?
It does.
Are you going to go with a paid, known certified solution, or are you going to rely on open source? And that's some of the trade-off that different vendors are going to make.
One of the brand personalities that Infineon brings to the table is dependability. Infineon's Oryx microcontroller is very well known for high safety, high security. It also, dependability means reliability, availability, and so on and so on. Maybe just to elaborate a little further on your comment there, Dan, for safety and security. I mean, how are you approaching that? What are you offering? And how does RISC-V come into play? You have a long history with RISC-V, actually. It's not something brand new to you.
Yeah, so the whole idea around safety and security, as it relates to RISC-V, and I think it's probably, I don't think it's known very well on how long we've been supporting RISC-V from a safety certification perspective. We've been doing it for almost a decade from a tools perspective and a real-time OS perspective. And I think it's probably not so clear how long ASIL certified IP has been available and incorporated into some applications. There are providers for IP, Synopsys being one, Andes, MIPS. There's people that have lockstep ASIL IP that's available to use and license, and Infineon knows that pretty well because of some of the things you're using. So, there's not only just the availability of it. So, we focus on the foundational side of the software ecosystem for the RISC-V, the tools, the operating systems, and some of our basic middleware. And, I can tell you that with it's not as well known because there's quite a bit of RISC-V that's actually being deployed, millions of units today, and it's not a accessible IP in the SoC. So we're actually working with a lot of companies today and helping them develop that RISC-V code under safety and security standards, and it's being deployed today. You just don't see it. These chips, these SoCs, they have 20 plus processors in them. You only see about 12, 14 of them. The other ones are the boot processors, the security processors, the other things you can't get access to.
Peripherals and so on, yep. So once the code's developed, applications developed, what kind of problems do our customers see, Rolf? They obviously need to be able to visualize the execution of the tasks and so on and debug their code. You have a long history as well, I think, with RISC-V and other industries. How do you see, your tools helping to evolve the ecosystem for automotive microcontrollers?
Yeah, my colleagues are active in the RISC-V standardization, specifically on debug and trace already for many, many years, and really co-developing or really working together when the pioneers of RISC-V get their new chips. already pre-silicon to ensure that all the debug tools are working for the power on and post-silicon and field returns. So far actually it runs relatively smooth. The specs are there. So that's actually also a change really, right? Benefit of open source. The specification documentation is all readily available. It's available before the silicon. Everybody can look at it. The challenge typically is then with the good thing on RISC-V is all the flexibility. Yeah. But it's also a bad thing in that regard that everybody wants to do their own stuff, and somehow you need to find then the right way and how to integrate it, how to support it. And that's right now a lot of manual work. And I hope actually we can a little bit more streamline that one. I think that's why, yeah, Infineon and Quintauris are really essential somehow to streamline all the variety into one so that we can actually focus on the right things. But then, well, as you know, we do all the heterogeneous debug. So if customers are using it, at least from the debug point of view, it's relatively straightforward. So I don't see really any major issue there.
Okay. There's research out there that says the OEMs, if you total it all up, software bugs cost around a double-digit billion-dollar number. Have you ever heard that, Dan?
That sounds about right. Yeah.
Yeah.
And it's not getting any lower either. Yeah. Yeah. I mean, it's not getting any lower. And one of the challenges we've been talking to the OEMs and the technology providers to the OEMs about is it's not going to get any better as long as you continue to follow the same development techniques, processes, and practices that you used that didn't work before that got you to this double-digit billion-dollar recall problem. So you have to really be thinking about, and as the OEMs are starting to take on more responsibility, they have to think differently about standardizing on using something like printf for their debugging of 100 million lines of code. It doesn't work, doesn't scale, you never find it. So there's a whole different direction, a way you have to think about how you're going through the whole process of developing your product, from the time you pick your IP to you're bringing up your hardware and the low-level debug aspects to the processes of how you write your code and the understanding of how you make sure that you're reducing the complexity on how you're writing it, and how you test and validate and integrate it, and all these steps have to be thought through, and it's a all-encompassing big challenge, but things have to be different. If they're not different, then they'll just end up being the same, and we know what that definition is.
And I think that's the beauty of this pivot we're in the industry, is that they are looking more for the technology providers to be advisors versus someone who just sells them something they need to put into the architecture. They're really trying to bring us in earlier in the conversation to really identify what does this architecture need in order for us to realize the software-defined future.
Right. We're talking at this level, our compilers, debuggers, operating systems, AUTOSAR. But if you look at really what we're trying to accomplish, you talk to some of the traditional OEMs, they still take 4 years to develop a vehicle. 4 years for a model year. How do you get that down to 18 months?
Yeah.
Like some people are doing today in China, right? How do you do that? How do you do China speed? Well, you don't do it by doing the same things you always did that took you 4 years to do. So these are the things that we really have to help our customers with across the board.
Very true. So again, pivoting into tech companies starts with vehicle architectures, abstracted software, so application layers are on their own track. How can they start to develop their application code sooner so that they can meet faster time to market, right? Maybe one of those answers, Rich, is on your side. Yeah, you're also not just the IP guy, but you're providing tooling for virtual development and so on. And so this whole shift left mentality of developing application software in the automotive industry is really starting to take hold, but it's not across the board at every OEM, but many of the bigger guys are moving in this direction. Would you agree?
Oh, absolutely. Yeah. I mean, that's we're on the IP side, separate from the EDA side of Synopsys, but the virtualizer, the virtual models, that there's a lot of focus on Synopsys on that, right? Absolutely, that's the long pole in the tent, is that application development. Like I said, as these become more and more complex applications with lots of moving parts, that becomes even more critical, right? To realize what Dan's talking about, to be able to get that down to 18 months, you can't start, the day that you tape out and say, all right, now I'm going to develop my software, right? It has to be, months or even years in advance, with models well before the IP and certainly the silicon is available.
And we also heard this morning AWS coming into the picture, right? So
Yeah.
that hyperscaler technology, we're bringing virtual development tools with all of our technologies, virtual models of our chips, software, debuggers, compilers, and so on, are available up in the cloud, and now everybody can start to work on their solutions around the globe 24/7, so you have a continuous CI/CD systems and so on.
Yeah.
I mean, are you all working actively on these type of projects with our customers? I mean, it's not just AWS up here talking about it, is it?
No, and AWS is one of Vector's collaborators, because
Yes.
for us, we recognize, like I was mentioning earlier, we are heavily invested in this whole software factory concept, because we recognize at the developer experience level, something has to change. It has to be different in terms of the processes in order to get those products out in the market quicker. And so for us, we're definitely looking at, okay, who are the right set of collaborators for us to get going quickly and to give our developers, our customers, the right experiences, because they don't want to have to, be bogged down with setting up all the necessary, let's say, components to create this IDE. That's not what they want to do. They want to be able to take one framework that fits their profile for their use case and be able to go and integrate their application, integrate it with the platform, and then be able to test it out in a virtualized ECU, the shift left, and then continue to test against whatever they're trying to create, whether it's certain functionality or feature sets for that next gen architecture. And if they're bogged down with the details of how this happens, it just slows everything down, and then they're stuck and they're disgruntled because they're upset that we didn't do the part that we could have done in terms of making a true impact in the industry and bringing together ourselves and collaborating a little bit more closely. And so I see the momentum of collaboration, and I'm a big believer in breaking down the silos and identifying ways we can better work together. And I think this panel is a testament of how we are working better together, and ultimately for the end customer, which is the OEMs and the tier ones in the automotive case.
Yeah, the value chain is changing.
Yeah.
And
It's changing in a very good way.
In a good way,
Because
yeah.
we were so siloed for so long that we just kept our own IP, our closed source thought processes within our own four walls, but the OEMs do need a more systematic view, and they need solutions that reflect that to help them get to market quicker.
And I think the main reason is, Danny brought it up, they are owning their own software development and system definition, and it's changing the whole way we collaborate, and it's not just tier one's calling on them and then we're all in the background. We're all in the same boat. And there's even new terms coming out of there. There's, tier 0.5s, there's, software tier ones, right? And so, yeah, it's a matter of collaboration. I just want to bring this up really quick. I mean, I read a book not too long ago. It's called The Ecosystem Economy. It's a great book. It's about how, our sectors that we know today are being broke down because of the advent of data and supply chain. So it basically means anybody can, come in adjacently on industries and start to compete. Banks are no longer the companies or entities that can predict if somebody will foreclose on their loan, right? I mean, Amazon can do this, Meta, everybody has data, so it's just, re-architecting all of our sectors. And so, I mean, it's a really good book, but it distills down to the automotive industry and what's going on, at the OEM level and this collaboration model that you just mentioned, yeah. We got about 10 minutes left here, and, we can't walk off this stage unless we talk about AI, right? So we had some very good discussions this morning in the keynotes about edge AI, and so obviously when we're talking about 32-bit microcontrollers, we're not talking about HPCs and servers and cloud, we're talking about devices on the edge. And so we're preparing for that. Obviously, RISC-V has a number of extensions that we've discussed throughout these last 2 days dedicated towards AI and edge AI and so on. So is the world ready for this in automotive? I think, we have solutions. Even some of our current microcontrollers with the ORIX have some machine learning, vector-based solutions. But where do you see the industry going with which use cases? Where's the imagination, at with machine learning, AI, and automotive? Yeah. I
mean, it's just like anything. I think for us anyway, the biggest challenge is AI is kind of like IoT was, 5 years ago. Ask, 10 people what AI is, and you'll get lots of different, like you said, maybe 15 different responses, right?
Yes.
So the interesting thing is, what is the level of AI that's required for a particular application and particular implementation, right? And so, it's everybody kind of thinks NVIDIA GPUs, right, on the training side of things, but at the edge and inference side of things, that may not be, and likely not, a realistic implementation just based on power and area and whatnot. So we have to come up with other MPUs, other, sort of ways to model, machine learning and AI, and maybe even baby AI, if you will, that, can be within the resource constraint envelopes that a lot of these microcontrollers and, battery operated things need to support. And that's a challenge because it's not easy to program those things, right? It's not like a normal, get a compiler and write some C code and there you go, right? These are complex graphs, and, being able to program them is a big challenge. So I think, there's the hardware implementation side, but I think the software side of it is a huge challenge.
I think the problem is really predictability, and then how you certify it, right, in the end. I think AI, yeah, you can use it. I think it's already there, right? You can use it in different scenarios, but how do you really want to trust it in the end, in all circumstances? Can you test it for all of those? It's because it's not easy predictable. I think that's really the challenge. When that's solved, then yeah, why not?
Do you have a solution for this?
No, currently not. Sorry.
Yeah, that's the state of the art of where we're at, so.
Yeah, I just want to add one point. I had some recent customer conversations, and one of the things that they were very interested in seeing is kind of a co-pilot type of experience around like configuration and integration activities, and being able to have a co-pilot with them right there so that they could test out different scripts and whatnot. So I think that level of AI is something that's super interesting at the developer level with consumers, because I've heard it repeatedly. So that's definitely something they want as a part of their experience.
Yeah, I look forward to the day when it's a part of our lives, and each piece of technology, a vehicle is just a very complex IoT of things, right? I mean, Internet of Things. Yeah. It'll be a very personalized experience for every individual, and then you can take that profile when you buy your next vehicle, and then it's just, ported over, if you will. Yeah. We work with some other ecosystem partners who are AI specialists. They sell, their models and prediction models and so on, and they work in other industries too. For lawnmowers, for example, it will learn your lawn, and understand where the lawns grow faster in that part of it. So it'll go attack that first when it has the most power and batteries. I mean, it's just, I look forward to this, world when it arrives. But we're on the precipice, and
Yeah, and as
Yeah.
new talent comes in too, I think that's part of the onboarding process. Instead of going through like these manuals of how to set up, like, you know, work through different tool sets or whatnot, they can easily just ask the agent a question and then be able to implement what it says back and see if it does what it's expected. So they're really wanting kind of this co-pilot thing to help get going. It's all about getting going quickly. They want to act fast. Period.
Very
They
well
don't,
said.
They don't want this arduous, I have to read this 500-page manual to figure out how to make this work for me.
That and even you know, all the data that's collected at the edge can also in real time, you
Be
know,
loaded up.
be
to-
loaded
yeah.
up, more training to be done, loaded back down, you know, as long as there's a connection. Obviously, if you lose it, it's okay, you know, but
And that's another AI experience, right?
that's
In
another
terms
AI
of
experience, yes.
getting the feedback from what's out on the market and trying to identify ways to improve it. So yeah, there's so many different, to your point, you ask the question AI, you're gonna get 50 different answers because there's so many different perspectives and different types of.
Yeah, just what you're talking about. You went to like the developer side, you know,
Yeah.
and using AI there. And what I was originally leaning toward was in the car, right? The
Yeah.
AI of radar, lidar, vision systems, you know, and obviously very different perspectives, but perfectly, you know, within the realm of quote unquote AI. in terms of-
Exactly. It's wild, but it's opportunity.
Very good. So we're about ready to close the panel down. We have a few more minutes here. I just kind of wanted to ask a closing question. If you guys have any final comments, but where do you see RISC-V in automotive in the next 10 years from now? You know, you want to go first, Brandy?
I'll go second.
Second. Okay, yeah. That's good. Sometimes be a fast follower is the best place to be.
Sometimes
Yeah.
fast follower
yeah.
is
I'll go
best.
first.
Yeah.
Okay,
Thank
so-
you, Dan.
Okay, so RISC-V in the next how many years?
Let's say 10 years.
10
yes,
years,
yeah.
okay, 10 years, starting today.
Starting right now.
Starting today, all right.
Yes.
Well, as I was alluding to earlier, RISC-V is already in the automobile. You just don't see it, you don't have access to it from a tier one and developer perspective. So what will be happening will be the evolution of those RISC-V engines being accessible and programmable for the OEMs and the tier ones that are developing the ECUs. And it'll start out more with the microcontroller side of things, the zonals and those types of areas of the car, the areas that are deterministic, real-time, and they maybe have some safety and security requirements. And you know, some of the decisions that are going to drive that are what Infineon's doing with its portfolio of solutions that they're bringing out, enabled with the Synopsys IP. So you know, you're looking, you know, it's already evolving. It's already there. It's just taking the next steps to be more mainstream, to be honest.
Any other opinions about it?
I mean, we certainly have our desires, right? I mean,
Yes.
we sell RISC-V based IP, and certainly automotive is a big focus for us. So we absolutely hope that, you know, what Dan's alluding to will absolutely happen, that RISC-V becomes the mainstream processor of our ISA of choice in the industry for automotive. So yeah, we see the initiation of that, right? We see it becoming that. I think the Quintaris thing is a big statement there, right? Getting basically competitors to come together, at least with the idea that they're promoting that standardization of RISC-V in automotive.
And so with a common architecture, scalable architecture, software ecosystem, do we believe that we're going to be able to help our OEM customers at the end of the day pivot into the tech companies that they want to become? Some of them are well underway, others are challenged with that, but I believe what we're trying to say here as a panel is that, you know, Infineon Technologies is bringing the microcontroller RISC-V, and along with our ecosystem partners, there's a soft landing. It's not going to be totally disruptive technologies. We already have a lot of experience coming from other industries, coming from different technology angles, compilers, debuggers, software, obviously the IP. And so at the end of the day, the main message is that together we can make this happen. And we look forward to the next 10 years, or the next 15 years, as RISC-V is now in its 15th year. Yeah. So I think that's the end of our panel. I'd like to thank all the panelists for attending. I really appreciate you accepting this invitation. Also, on a very short notice, I was kind of tasked with putting this together very quickly. So I'm very good, close cooperations with these members. So I'd like to thank them for joining me here today. So thank you very much.